Hello everyone, let's take a look at our next problem. Show that when you square an odd number, you always get one more than a multiple of 8. Okay, so my first thought is something similar to the previous question I solved. The first thing we're going to do is, if you have an odd number, you know that it is one more than an even number, and an even number must be a multiple of 2. So we're just going to write all of that out. N is equal to 2k plus 1. And then I want to show that n squared is a multiple of 8. So I'm just going to square both sides of this. Sorry, not n squared is a multiple of 8. It's one more than a multiple of 8. So n squared is equal to 4k squared plus 4k plus 1. Okay. And so this gives me 4k squared plus k plus 1. And what I want to do now, I'm looking at this. If I can show that this thing is a multiple of 8, then I'm done. But I already have a factor of 4 here, so I want to show that this thing in here is even. Okay, well, if k is even, then k is equal to 2m, which implies k squared plus k is equal to 4m squared plus 2m, which is 2 times 2m squared plus m. Okay, so there's my factor of 2, and I'm happy. Or, if k is odd, then k is equal to 2m plus 1 for some value of m. And so k squared plus k is 4m squared plus 4m plus 2 plus 2m plus, oops, this should be a 1, 2m plus 1. And this is equal to 4m squared plus 6m plus 2, which is 2 times 2m squared plus 3m plus 1. And there's my factor of 2. Okay, so regardless of whether k is even or odd, this thing k squared plus k is a multiple of 2. Okay, I don't know what this number c is, but it doesn't matter. I know that this thing here is even, meaning it's a multiple of 2. And so I'm left now with my factor of 8 in front of factor of 8, or a multiple of 8 plus 1, which is exactly what we were looking for. Yeah, so the first intuition I had here, simply to write n as being one more than a multiple of 2, and then expanding and sort of figuring out the consequences of this representation of n, is pretty much all that was necessary. Thanks for watching.